Good morning and welcome to Wednesday. Thank you for showing up for your learning this morning, everyone. I'm not there with you in person. I am there with you in spirit, and I am available by email if you have questions. I love receiving your questions by email, and I take a look at the Delta Math that you're doing to see who's struggling or who's just crushing it already. So to give you a tour of what we're looking at today, yesterday we looked at linear systems by substitution. And today we're looking at a new method to solve linear systems algebraically, and it's the elimination method. There's a Delta Math assignment for you, and there are questions in the textbook also for your practice. Now, let's get right to it. So you should have by now taken a look at this linear system here that you can solve with substitution, the method from yesterday. If you haven't done that yet, let's pause the video and give you a chance to solve this one by substitution, and then you can take a look at my method as well. All right, so let's go through it step by step. So to solve the system by substitution, I do want to make sure I can identify a variable I can isolate. Once I can solve one of these equations for a variable, I can then sub it into the other equation. So step one, label my equations. I like A and B, but if you like Q and R, label them Q and R. Okay. Now I'm going to rearrange A because I see that it's very easy to arrange for Y. So let's write that down. I have 2x plus y is equal to 7. Let me add negative 2x to both sides. Why'd you say add negative 2x, Mr. Jennings? I could subtract 2x from both sides, and they'll be the same. All right, so now bring this down. Y, 2x minus 2x, 0. I don't write 0. I don't write 0 every time it shows up. So then I would have negative 2x plus 7 on the other side of the equation. Hold on one moment. Okay, so let's carry on. So I now have my equation rearranged for a y. And there it is. So let's take that and substitute it into the opposite equation. I need to remember this is a rearrangement of A. So I want to substitute that into B. So let's write B down. 3x minus 2y is equal to negative 7. I'm going to substitute this in here. 3x minus 2 multiplied by negative 2x plus 7 is equal to negative 7. All right, let's keep going. So now I have one equation, one variable I can solve. So expand. So I want to remember this negative 2 is the thing that I'm going to expand into this bracket. All right, so I have 3x. Negative 2 times negative 2 is plus 4x. And the negative 2 times positive 7 is minus 14 equals negative 7. Now, I just need to collect my like terms, and I push all of the numbers to one side of the equation and all of the letters, all the variables, to the other side. So conveniently, the x's are on the same side of the equation already. I have just the need to add 14 to both sides, and then that goes to 0, and I have 7x equals negative 7 plus 14, that's 7. Okay? If 7 times a number equals 7, the number is 1. All right? Divide both sides by 7. X is equal to 1. Circle it, that's half your answer. Now I'm going to substitute that into one of my original equations. Oh, A looks like the easiest one to work with, so let's use A. Okay? So A. All right? 2x plus y equals 7. 2 multiplied by x plus y equals 7. X is equal to 1, so I can say let x equal 1 here, sure. And then I have 2 multiplied by 1. I'm off the page. 2 multiplied by 1 plus y is equal to 7. 2 plus something equals 7. Something must be 5. Okay, subtract 2 from both sides, and I get the line y equals 5. Circle it. Final answer is these two together. So then I want to write a therefore statement. I'll write it over here. Therefore, the solution is 1, 5. Great. Now, today, we're going to be learning a new way to do this algebra. All right, it's a different method, and it is called elimination. So, elimination is it's pretty neat. It's a cool trick in math, and sometimes it's super convenient to use the elimination method instead of the substitution method. So that's why we're going to take a look at it. Now, 9 times out of 10, I use substitution. Even when I'm doing things in my head, I'll usually use a substitution method. Okay, let's keep going. So we're going to be using the addition property of equality. All right, we can add the same value to each side of an equation. And you see me doing that in my inverse operations, even when I'm doing substitution. But now we're going to take equations. We know that, say, like x plus 5 equals something. We have an equal sign in the middle. These two things are the same. I can add 1 to one side of the equation and the other to the other side of the equation. I'm still following the rules of math. We're going to see some examples of that in just a second. So we can do this to eliminate a variable from one of the equations. And that gives us one variable, one equation we can solve. All right, so let's try an example together. Well, I'm going to do it and you're going to copy. So I'm going to flip over to the document camera and we're going to do this equation, this example next. So you have this example on your handout. I'd like you to copy this as I do it and see how we go about solving these. First step is always label your equations. I like A and B. So this is my equation A, this is my equation B. Next, I want to choose to multiply both sides of one of these equations by something such that the coefficients of one of my variables will be the same value but opposite signs. I have 2 children at home with me today, so they're helping arrange my papers for some reason. Yeah, leave my papers alone. You're costing all the students time. Okay, so I want to multiply one of the equations by something so that these coefficients will match. Now I have a couple choices. I could choose to eliminate the x, or I could choose to eliminate the y. I see that the y already has an opposite sign, and I like that. Now, you can do these when you're and subtract equations from one another. I don't like that method. I will always teach you addition of equations. And this will help avoid common student errors that I see far too often. So I don't teach the subtraction of equations from one another anymore. Just do the addition of negative equations, okay? So let's say I wanted to eliminate x and solve for y. I'm going to change this coefficient so that it's a -3. I want it to be the same value as that, but I want it to be negative. So let's set that up. Here I'm going to do -3 multiplied by a. Okay, so I'm going to multiply -3 times x minus 2y, and that's going to be equal to -3 times 6. All right, I'm just multiplying both sides of this equation by -3. Okay, now let's carry on. Let's do that. So I have now here -3x plus 6y is going to be equal to -3 times 6 is -18. All right, so that's my rearranged 3a. Well, it's -3 times equation A. Now I'm going to go ahead and write down B, and I'm going to add B to that. B is 3x plus y equals 11. Okay, so I can actually do this, and I'm just going to block that off so that you see I'm working here, and I'm going to add these together. This is going to equal, actually, I don't write that equal sign. I would never write that equal sign. The equal sign is going to come down the middle. Now I have -18 plus 11. So if we had -18, we're adding 11, it's now going to be 7. -7, I'm sorry. The flavor is important. And then here, -3x plus 3x, that's 0. 6y plus y, that's 7y. Now I have 7y equals -7. One equation, one variable I can solve. So how do I solve that? I get my inverse operations pen out. I divide both sides by 7. Now I get the line y is equal to -1. Okay, so I added these equations together. I got this. Now I solve for one of the variables. Boop, 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 boop. Circle it. You're going to use that as part of your answer. Now find the other variable. Okay, now you're going to find the x. Okay, so how am I going to do that? Well, I can substitute into one of my original equations. Let's substitute into a. That looks pretty easy. X minus 2y equals 6. So I had y is equal to -1, so put that in for y. X minus 2, substitute into brackets, please, -1 equals 6. -2 times -1 is +2. So I'm just going to move this up here. X plus 2 equals 6. Subtract 2 from both sides. Gives me x equal to 4. Circle it. Okay, now it says I should check my answer. How do you check your answer, Mr. Jennings? So many ways. One is I can substitute these into these equations and check. Okay, this is good mental math practice. You want to be able to do this fast. So I have y is -1 and x is 4. Don't worry, that's not a real siren, that's a toy. Okay, so y is -1, x is 4. So let's see, does that work here? 4 minus 2 times -1. Well, that's 4 plus 2. 4 plus 2 is indeed 6. It works in that equation. Let's check here. 3 times 4 is 12. Y is -1, so that's 12 minus 1 equals 11. That's true, so it works in that equation as well. Okay. You could also put it in Desmos and see if the two lines touch at that point. So let's do that. Let's do that quickly. Here, I'll pause the video and. All right, everyone. So here's a graph in Desmos of our two lines. The blue line is coming down and touching the red line there at 4, -1. So Desmos also confirms the work that we've done. So that's using elimination to solve these types of questions. Let's carry on with the PPT. So what we want to do, and they will do this in the PPT in a different way. So I'm just going to keep going. Now, we want to do some more examples. This next example we've already done by substitution. And actually, you could use substitution as a method to check your answers. And let's now try and solve this one by elimination. So we're going to work on this one together. As I'm working on it, you're going to work on it. And then we'll take a look at it. So let's go over to the document camera. And I'm going to go ahead and solve this problem while you solve this problem. Then look back up, see if your method is the same as mine.
And don't forget to smash like and subscribe.
You really liked that, didn't you, from yesterday? Smash like and subscribe. I was trying to make a joke, honey.
Hey, now they won't do it. Now they won't see more of your channels. Or read in the comments down.
Zara, please shush. Everyone is working hard to solve this problem. We are all working on it.
Even me.
Yeah, even you. Okay, so there's my new equation. I'm going to write down 2a plus b.
Daddy, do you mind sharpening this?
Yes, I'm not going to sharpen a pencil for you right now. Oh no, my inverse operation pen is running out of ink. Now
You can borrow one of mine.
Up here. It's fine, Zara, I'm okay. I'll use A.
And I have a blue one too. So it runs out, you can trade me for your pen and I can give you one of my pens. Oh. That's a big work. Okay, where's my
I'm off the screen. Sorry about that. The solution is 3, 1. Right. Now, okay, so if you still need more time, pause the video. Or if you just want to compare your work to my work, here's my work here. So let me just zoom out just a touch so you can see everything, or I'll just make it full screen. Zoom in a touch. So what do we do? What have you done here? You have, perhaps you did this, where you saw, okay, if I multiply this equation by 2, I would have the same value coefficient, but opposite sign here. That would create this equation, 4x plus 2y equals 14, which is just a rewriting of that equation. Then I add that to this. That gives me 4x plus 3x equals 7x. 2y minus 2y gives me 0. 14 plus 7 equals 21. Divide both sides by 7 to get x equals 3. And then I go down here, substitute my x in to solve for y equals 1. And then I forgot to do this on the previous question. Oh my goodness. And it even reminded me over here. It says the last thing you should do is write a therefore statement. Okay, so the last thing you should do is show that you know you have solved the question. You write it by saying, therefore, the solution is the point, 3, 1. And write your answer as a point. So that's going to be very useful to your audience so that they know what you've done and that they know that you have solved the question. Give me one moment. Okay, I'm back and I found my mistake. So my mistake was we both did different questions. This should be -7 and not +7. So my apologies. That would change the answer quite a lot. Okay, so I have -7 here on the PowerPoint and on your handout. And then when I wrote it down here on my sheet, I have +7. I'm quite confident my work is correct, but let's just change that in my work so that it will match yours and we will all learn from this mistake together. So let's go in wide. And as you can see, I'm in a distraction-filled environment. And so we embrace our mistakes and we learn from our mistakes. If I have -7 here, I would also have -7 there. Instead of 21, this would give me 7. And I would have x is equal to 1. Okay, there. And then I would have 2 times 1 is 1. And then, so this would be 2 instead of 6. So I'd have to subtract 2 from both sides. That will give me y is 5. Okay. Now it's the same question that we did earlier. Now I can check and see, did we get the same answer before? Yes, we did. Okay. So if you were confused by that, I hope that seeing it this way will clear up that confusion. And let's do one more example together so that you can get some more practice. This one, I will pause the video. I will complete the work. You're going to pause the video at your end, complete the work. Once you're finished as a class, you can turn the video back on and we'll discuss the solution. Dun, 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 dun. The fastest way is graphing. If you could just type into Desmos and you can find your answer. So for those of you who have finished, the answer is 3, -2. Okay? So let's take a look at the solution that you came up with. I'm pretty sure mine is going to be different than yours, and we'll talk about how. Okay, one thing that I mentioned is sometimes you can multiply both equations by a number to create those coefficients that will eliminate. And I'll show you what I did here to do just that. Yeah. Okay, so here's first step is label my equations. I have equation A and equation B. And then I decided I'm going to eliminate x's. All right, I can do that by multiplying equation A by 3 and equation B by -5. See where I got my numbers? I just took the opposite number and multiplied each one, kind of like cross-multiplying when you're working with fractions. Okay, and that created a line. This is 3a. This is 15x plus 12y equals 21. And this -5b is -15x minus 10y equals -25. Excuse me one moment. Okay, just a quick indoor voices lesson. Now let's go back here. Sorry to be jumping back and forth, but I can't pause the video from in here. Okay, so anyway, I have these two lines, 15x plus 12y equals 21 and -15x minus 10y equals -25. I created those by multiplying my equations in that way. I did the work up here and then I write them as an addition. So that gives me, eliminates my x's, gives me 2y equals -4. So y is equal to -2. Right? And then down here, I substitute the y equals -2 into one of my equations. I see that 4 times -2 is -8, so I have to add 8 to both sides. Gives me 5x equals 15, so x is equal to 3. And then check your work before you write a therefore statement. Here's where I checked my work. Over here, boop. Right there, 3, -2. So I got it. All right. So now, the last thing is to write a therefore statement. So then my therefore statement looks like this. Therefore, the solution is 3, negative 2. I get that there, 3, negative 2. Okay, and so that's how I approach these types of questions. Now, this is the elimination method. You can also use it for applications. So let's take a look at the application that we have in here inside of PowerPoint. And this will help you organize your thinking for the examples, the application examples that are in your textbook practice for this afternoon. So let's put me up there, present. Okay, so as a birthday gift, Zoe gave her niece an electronic piggy bank that displays the total amount of money in the piggy bank as well as the number of coins that have been deposited. Pretty cool. So Zoe has a collection of nickels and quarters, and she's deposited $2. She's deposited it with 16 coins. We want to know how many nickels and quarters each did Zoe put in the bank. Okay, so I'm actually going to work with you over here on the handout. Okay, so let's make this bigger. Move me over here. Make this bigger. All right, so how many nickels and quarters did Zoe put in the bank? Well, let's see. First thing I want to have is my let statements. Let X represent the number that I don't know. I'm going to choose the things that I don't know. I'm going to make them letters. Okay, so what don't I know? I don't know how many nickels. I also don't know how many quarters. Let X equal the number of nickels. Number of nickels. And let Y equal the number of quarters. All right, now I can create some equations. X plus Y. This is the total number, darn auto format, of coins. Okay, the number of nickels plus the number of quarters will equal the total number of coins. I know that that's 16, I was told. Okay, 16 coins. But I have a second equation that is, I have 200 cents here. 200 cents total in the piggy bank. Each single nickel gives me 5 cents. Each quarter gives me 25 cents. So I know that 5 multiplied by the number of nickels plus 25 multiplied by the number of quarters, that must equal 200. Okay? And I like lining up my equal signs this way. All right, now what I'm noticing is that I have two equations, two unknowns. I should be able to solve that. Call this equation A and this equation B. All right. Now I'm just going to copy equation A because I'm going to change equation A. I'm going to multiply it by negative 5. That'll eliminate X. I times that by negative 5. Okay. So let's write it again down here. Boop. And I'm going to multiply this by negative 5. Negative 5 multiplied by that, and negative 5 multiplied by the other side. Okay, oops, I'm sorry. There. Now, do the work. This is negative 5a. Okay, great. So now I'm going to bring that down and just evaluate. Negative 5x minus 5y is equal to negative 5 times 16. Negative 5 times 16 is 80. Negative 80. So I have negative 80 there. Okay. So now I have my two equations, and I'm going to add them together. I'm just going to take this equation B and bring it down here. Boop. And then line up my equal signs there. So now I have my equations that I can eliminate, and they went onto another page. Thanks very much, Google Docs. So now I'm going to add them together. All right. So negative 5x plus 5x, that gives me 0x. Negative 5y plus 15y, that's 10y, is equal to, what's it equal to? Well, negative 80 plus 200. Negative 80 plus 200 is 120. Right. Now divide both sides by 10. That will give me y is equal to 12. All right. So I might highlight that and say that's going to be part of my answer. That's pretty important. All right. Now I'm going to go ahead and sub into A. Okay. I'm going to rewrite my equation A. I'm going to turn off the highlighting there. All right. And my equation A, I can just copy it from here. Copy and paste. But I want to be subbing y in for y, so that's 12 there. X plus 12 equals 16, so that tells me that x is equal to 4. All right. Now, why is x equal to 4? Well, I subtract 12 from both sides. So 16 minus 12 is 4. So x is equal to 4. All right. Now, I am going to highlight that. That's also part of my answer. And then I'm going to write my therefore statement. Now, those 3 dots that I write are therefore. Therefore, there are 4 nickels and 12 quarters in the piggy bank. There. And that would be a solution to that whole problem. So that's how I construct equations and then use those equations with the process of elimination to solve a real-world situation. Now, the real key there are my let statements. And those let statements, yeah, hold on one moment. I'm just about finished. Those let statements organize my thinking, which can be very disorganized at times in distracting environments. Classrooms are less distracting than homes. Yeah, you make your let statements, and that helps you make your equations. And then you can use elimination to solve those. So when you have questions about this and problems, email me, and I will help you out. Best of luck to everyone, and enjoy the rest of your Wednesday. Bye for now. Thanks for showing up for your learning.